Hello, in this video, I am going to go over the written homework 2.9. First one, you have a 200 feet of fence, so we know that all of the fence, the measurement is 200 feet. To construct a rectangle pen with a fence divider down the middle, just like the graph they show you. Okay, what dimension of the pen enclose the largest total area? So to get the area, and since this is a rectangle, that means we need to know the length times the width. So right now, I want to find the maximum of the area, but I don't know anything about the length and width. However, they told you that the total fence is 200 feet. So now we know another things. So there are two lengths. So that means two lengths we totally have 3 width. At 3 width is equals to 200. So that means I can use a W to use the width to represent the length, since they have this relationship. Now, what I can do is try to solve the length in terms of the width. Okay, so I have a 2L equals to 200 minus 3W, and then divided by 2 on both sides. Simplify it, I have a 100 minus 3/2 width is equal to the length. Then I can substitute the length back into the area. Then we have the area function equals to 100 minus 3/2 W times W. Why do we need that? Because to find the maximum of the area, we can use the first derivative to find the critical point, and then use the second derivative to find if this is concave up or concave down. Then we can determine at where of W we have the maximum. Now, let's simplify it first. I have 100 W minus 3/2 W squared. Distribute the W inside the parentheses. The next is finding the first derivative of the area, which is equal to 100 minus 3/2 times 2 times W. Simplify is 100 minus 3W. Now, we need to set the first derivative equal to 0 to find the critical point. So, let 100 minus 3W equals to 0. Then we can solve 100 over 3 is equals to W. That means when the width is equal to 100 over 3, 100 over 3 feet long, we have our either minimum or maximum. Now, we still need to test out if this is maximum or minimum. Let's find the second derivative at that point. So I have second derivative is equal to, 100 minus 3W, another derivative. So I got 100 gives you a 0, and then I have negative 3. So if it's negative 3, that means this is going to be a concave down. If it's a concave down, we're going to have a minimum. Okay, but again, the question is not just ask you at where you will find the minimum. At where means if the width is 100 over 3, we will have a minimum. We need to find the dimension. That means we also need to find the width and the length. Okay, we know that the length by the previous step is equal to 100 minus 3/2 W. So we substitute this back. We have 100 minus 3 half W. W is at 100 over 3. Simplify it, so I have a L equals to 3 and 3 cross cancel. We have 100 divided by 2, which is 50. So that means when the length is 50, and the width is 100 over 3, we reach our maximum. The area of the rectangle, I should say that. Okay, now let's do B. So B says, let me take a look. B is very similar. If you need two divisor, what dimension of the pen encloses the largest area? So we use the same method. But when you're doing this question, it's easier to draw a picture. So now this is the form, and we know that with a W, 4W, right? Because that needs you to have a full width, and then the length is the same, also 2. So the first relationship, width and length, we will get is 4W at 2L equals to 200 feet, and then we can solve for L in terms of W, or we can solve for W in terms of L. Either way works. Let's do 2L equals to 200 minus 4 times W, and then divided by 2 on both sides. I have L equals to 100 minus 2W. And now next is trying to find the derivative of the area. So area is equal to the length times the width. And the length is equal to 100 minus 2W times W, because you want to replace that in here. So instead of having two variables, now we just reduce to one variable. Then we can apply the first derivative to find the critical points. Okay, now next step is finding the first derivative. So I got 100W minus 4W. And then I want to set the first derivative equals to 0. So I solve W is equals to 25. So that means when the width equals to 25, we will have a maximum. But we don't know yet. It should be right, but we still need to go over the second derivative. So now taking the first derivative, then we will have a second derivative. So I have a -4, which is a concave down because it's less than 0. If it's concave down, that means the whole function is going to be a concave down. If it's concave down, that means this is our maximum. So L is equals to 100 minus 2 times 25. So that means L is equals to 50. So when the length, equals to 50, and the width equals to 25, the pen encloses the largest area. Okay, next one is what are the dimensions that in part A and part B if one edge of the pen border on the river that doesn't require any fencing? Well, this one is similar, but the graph is going to change. Instead of have two lengths, since the pen is enclosed to the river, so that means this is a river, and we don't need to build a fence about on that side, the part that close to the river. So that means when we set this up, if we have two dividers, we should have L plus 4 divider, 2 divider, which is 4W, is equal to 200 feet, and then you just find the first derivative and second derivative. If you only have one divider like this one, so your setup should be 1L plus 3 width equals to 200. Hello, now let's talk about number 7. For number 7 is determine the dimension of the least expensive cylindrical can which will hold 100 cubic inches if the materials cost 2 cents, 5 cents, and 3 cents respectively for the top, bottom, and side. Again, when it comes to question like that, it's better for you to draw a graph so you can visualize the problem. Okay, so this is the cylindrical pen, and then they know we want to hold 100 cubic inches of material. So that means the volume of this cylinder is going to be 100 cubic inches. So to get the volume, first of all, let's do some reminder about the formula for the wall of a cylinder. Cylinder is equals to the height H times the area of the bottom, which is pi r squared. We don't know the height, we don't know the radius of the surface and the top, so that means we need to find that. Again, we use the same trick that we did earlier. We know that H pi r squared equals to 100, then we can maybe use that to represent one of the variables, so we can minus it down. Remember that pi is not a variable, pi is a constant. It's equal to 3.14, approximately equal to 3.14. So now let's try to solve for h in terms of r. It's equal to 100 divided by pi r squared. Now, I am going to write 3.15 times r squared. So now it's easier for us to understand that, hey, h, we can solve for h in terms of r. Now the next is we want to minimize the cost. So the cost has 3 parts. One is 2 cents. I assume they mean 2 cents per square inches, because when it comes to a cylindrical can, when you build it, is the surface area that we need to calculate the cost. So I'm going to label that on our graph as well. For the top is 2 cents. Bottom is 5 cents. And then the sides are 3 cents. Now, how do we find the area? The surface of a cylindrical. The surface of cylindrical is, we have a top circle, the bottom is also a circle, but the side, the cylindrical body, when you open it, just like this book, this notebook, when you open it, unroll it, it's going to be a rectangle. The height is going to be the width, and then the circumference or perimeter of the circle is going to be the width. Think about that. If you have any paper, just roll it to become a cylindrical and then unroll it. Then you will see that. Okay, so the total cost is equals to 2 cents times the top circle area plus 3 cents times the body rectangle plus 5 times, which is 5 cents times the area of the bottom circle. So here's my note. I write this out so when I try to fill this in, I'm clear about which one is which. Okay, so the area of the top circle is equals to pi r squared plus 3 times the body. Remember, the body is equals to h times the circumference or the perimeter of the circle, which is pi d or 2 pi r. Pi times 2r, oh, d is diameter. And then add the bottom, which is 5 times pi r squared. Now let's merge the like terms. Also replace the h with 100 divided by 3.15 r squared, or maybe keep it pi. Either way, we can keep it pi. Let me try to keep it pi and see what happens. So these two are the like terms. So we have 7 pi r squared plus 3 times 100 over pi r squared times pi 2r. Now simplify everything. We got pi and pi cancel, r and r squared, we can get rid of one of the r. Then we have 7 pi r squared plus 600 over r. Right. Now, next part is finding the derivative of the total cost. So the derivative of total cost, we take derivative of r, so I get 14 pi r plus, this is going to be a negative, because we have a -1, negative 600 over r squared. And we want to let the first derivative equals to 0. Now we can solve it. We have 14 pi r equals to 600 over r squared. Multiply r squared on both sides, and then we have 14 pi r to the cubic equals to 600, and then divided by 14 pi on both sides. Now, then I have r to the cubic equals to 125, and then take a cubic root. So r is equals to 15 or 25. I think it's 5. 5 times 5 is 25. 25 times 5 is 125. So that means our radius is equals to 5 feet. Okay. The next part is we still need to test if this is a concave up or concave down at r equals to 5. So first derivative, take another derivative. We will have our second derivative. Just remember that during your calculation, pi is not a variable, so we can take derivative of pi. Pi is a constant, equals to 3.14. Now, taking derivative of r, we have 14 pi minus, or plus, now is 600 r to the cube. And then we need to substitute r equals to 5, at that point, see if this is concave up or concave down. So okay, so this is always greater than 0 because 14 times pi is greater than 0 at a positive number. It's greater than 0. So that means at that point, this is going to be a concave up. If it's concave up, that means when r equals to 5, when the radius equals to 5 feet or inches, do they use feet or inches? Let me go back to the question and take a look. Inches, they use inches. So when r equals to 5 inches, the cost of the can is minimum. It is minimum. And we still need to find the height because we need to know the whole measurement. The height is equal to, by our previous, we have 100 divided by pi r squared, which is 100 divided by pi r squared is 25, so it's 4 over pi, which is 4 over 3.14. You can keep it that way, you can keep it decimal, or you can just leave it 4 divided by pi, either way. So the legs expansion to build a cylindrical can with the radius of 5, and then the height is 4 divided by 3.14 to hold 100 cubic feet of material. So that's number 7. Okay, so B is similar. You will use the same way to do it. It's just the setup is different because they say if the bottom material costs more than 5 cents per square inches, in that case you can assume something like 6 cents or 7 cents. So just check this out by yourself. Now let's go over the next one. Okay, now let's take a look. Number 15. You own a small airplane which holds a maximum of 20 passengers, and they require that the minimum to hold as the minimum number you will fly is 10. So the amount of people you're going to fly X has a range is from 20 to 10. That's important. Second, the cost for the plane is it costs you $100 for that flight, and the additional $6 per passenger for extra gas required by the extra weight. The charge per passenger is $13 if 10 people are charter your plane, and then the charge will reduce by $1 per passenger for each passenger over 10, such as if you're flying 11 passengers, they will only need to pay $29. If there are 12 passengers to fly with you and then to charter your plane, you only need to pay, each of them need to pay $28. And then the question is, what number of the passenger on the flight will maximum your profit? Well, profit is equals to the revenue minus the cost. Now we need to know how do we find the revenue and how do we find the cost. The revenue is equals to the number of passenger times the sales per ticket. So the number of passenger that we don't know, we will let this equals to X, like that's how we defined it at the beginning of the question. The sale per ticket is a little bit tricky. It really depends on the number of people, but we know that they starting with 13 because the minimum requirement is 10 passenger, and each passenger get on, they're going to minus $1. So X starting with 10, so that means we're going to subtracting, depends on how many extra people after 10 minimum requirement. So we need X minus 10, which makes sense. If you have 11 passenger, each cell is going to be 11 minus 10, this is going to equal to 1, right? And then $13 minus that 1 is equal to $29. If you have 12 people, 12 minus 10, you have 2 extra people, and then the cost is going to reduce $1 per 1 extra people, so that means it's going to be 13 minus 2 gives you $28 per person. Now simplify it. So I got X times 13 minus X plus 10, which is basically is 40 minus X. And then revenue is 14X minus X squared. Now after we found the revenue, we need to know the cost. The cost of the flight have two parts. One is the various cost, the other part is the fixed cost. The fixed cost is, even though there's no one on the plane flying from St. Thomas to Crosses, it costs you $100. That's the fixed cost, which is $100 plus the varied cost based on how many passengers are on the plane. For the cost, it's going to be additional $6 per passenger for the extra gases required by the extra weight. So the total number of passengers is X, and then it's going to cost $6 extra per passenger. So the variable cost is going to be 6 times X. Now, after we have revenue and cost, we can write down our profit. It's going to be the revenue. Let me write the formula. Revenue minus the cost. Revenue is 14x minus x squared. Subtract, put the parenthesis, because if you're subtracting something, this is going to change the sign. In fact, it's better to put the parentheses for all the variable, then you know which part that you're replacing. That's the cost. And the blue one means the revenue. Now we move the parentheses and change the sign. I got 146x minus x squared minus 100. We want to have a maximum profit, so that means we need to find the first derivative to find out the critical point. I got 146 minus 2x minus 0. And then you want to set the first derivative equals to 0. Then I can have the critical points. So I have x equals to 23. Still, we are not sure about that, because critical point could be the inflection point, the minimum, or the maximum. The next thing we need to do is check the second derivative. The second derivative is take another derivative of the first derivative. So I have 0 minus 2. So it's negative. Negative means this is going to be concave down with all the x's within the range. So that means when x equals to 23, the profit reaches is maximum. Okay, that's number 15. Now let's take a look at number 18. So the total cost in dollar for Alicia to make cube oven mitts is given by, so the cost function is 64 plus 1.5 cube. I think it's the quantity plus 0.01 q squared. And what is the fixed cost? So fixed cost means that you're not going to change by the variables. In this case, the fixed cost is going to be the $64. B, find the function that gives the marginal cost. So the marginal cost is going to be the first derivative of the total cost function, which is equals to 64 plus 1.5q plus 0.01q squared, and then get the derivative equals to 1.5 at 0.02q. And then the next is the average cost. Average cost is equals to the total cost divided by the quantity. So I have 64 plus 1.5q, which is the quantity, and then 1 cent times q squared divided by q. Simplify it. I have 64 over q plus 1.5 plus 0.01 q. Okay. So part C is, hold on. So part C and part D is finding the minimum cost of the average, the minimum average cost. So we can take the derivative of the average cost. So I got 64 over Q plus 1.5 plus 0.10 Q, and take the derivative. And this is going to equals to negative 64q squared plus 0.001, and then you try to solve for q by setting up equals to 0. So it's 0 equals to negative 64q squared at 0.001, and then I got 64 equals to 0.001 over q squared, and then multiply q squared on both sides, and then divided by 0.001. Okay, let me do the multiply the q squared in here in case someone that they don't follow. This go away, and then I got 64,100 equals to q squared, and then take square root on both sides. So q is either equals to 80 or negative 80. And we know that since quantity, we're looking for how many MIDs we're going to produce. And in reality, we need to drop the impossible answer, which is when it's negative MIDs. You can produce negative item, right? So that's why Q should be your critical point. Again, you need to use the second derivative to check the answer, see if this is concave up at the point Q equals to 18. The next thing, the second method, I want to go over the second method. The second method to find the minimal cost is when the average cost equals to the marginal cost. Now, here, the average cost is 64 divided by 0.001 plus 15 cubed. No, is that 16 cubed? What's the average cost? Plus 1.5, sorry. Plus 1.5 plus 0.001 Q. These should be divided by Q. Equals to the marginal cost. Earlier, we found the marginal cost is 1.5 plus 0.002 Q. 0.02 Q, sorry. Then we can simplify it. 1.5 minus 1.5, they're gone. And then the next one is we add 0.1 Q on both sides. So 64 over Q equals to 0.03 Q. Sorry, I made a mistake. Here should be subtract 0.1 Q instead of adding. You may find that. Okay. And then you solve a Q by multiply Q on both sides. Then I have 0.1 Q squared because I want to get rid of the Q in the denominator. By multiply Q on both sides. And then you solve it, it will be the same. Q is either equals to positive 80 or Q equals to negative 80. So we're going to drop the negative 1. So no matter which method you use, you should end up to have the same answer. So producing 18 MIDs is going to minimize the cost. Oh, and now let's look at number E. Number E is confirm the average cost and the marginal cost are equal at your answer D. So basically, this is the E solution for E. It's supposed to be F. Oh no, E, sorry, it's E. Well, we just did it. Because this is another way to find the minimal average cost. Okay, number 19. Number 19 is Shaky makes and sells backpack danglies and the total cost in dollar for Shaky to make that Q items is to given the cost function. So number 19 is very similar to number 18. So I'm going to leave that to you and do it by yourself. Let me know if you have any questions.